Alright, welcome to this video about section 1.3. We just went over even symmetry, which is y-axis symmetry, and now we're going to see the other type of symmetry. So in this example, we're not going to spend a lot of time plotting the graph for problem 3. You're actually given the graph of the function in black, okay, y equals x cubed. And so the first question is to describe the graph of the function and determine whether it's even. And also, does it have any symmetry? Okay, so if it was even, that would mean that f of x would equal to f of minus x. And you are actually also given the graph of f of minus x, which simplifies to negative x cubed in the dotted red line. So because those two graphs are different, they're not the same graph. In other words, because the black graph doesn't have y-axis symmetry, then we can say no, it's not even because f of x is not equal to f of minus x for all x, or you can say it doesn't have y-axis symmetry. But it does have some kind of a nice symmetry, right? It's kind of a little bit weird symmetry to describe, but this is called odd or origin symmetry. So basically, like, you can actually see the definition 2 there. This is when f of minus x equals minus f of x for all x. So I can kind of try to explain this. So if you take like some value of x, let's say like we take this one, okay? So this is f of x right here, okay? So this is the point x, f of x. Okay, that's one. And then we're going to compare, so if that's x, then negative x is the point on the other side, right? And then f of negative x is the y value of the function. So this is basically f of negative x, where this one here is f of x. And so if the function was even, those two y values would be the same, but I think that what you can see by the graph is that they're opposite. So what we have is that although these two are not the same, they are opposite. So we know that in this case, f of negative x equals negative f of x, okay? We can check this algebraically for x cubed if you want, because like f of negative x would be negative x cubed, which simplifies to negative of x cubed, and then negative of f of x would be negative of x cubed. So this is like just kind of to show you again that these are the same. And then just more geometrically, it's an origin symmetry, which means like it's not only a reflection in the y-axis, but it's a reflection in the y-axis and then another reflection in the x-axis. So that's a little bit more complicated symmetry, but that's an odd symmetry. Okay, so to summarize in this discussion question whether this function has even or odd symmetry, it has odd symmetry. And I explained the reason for this up above because I computed that f of negative x equals negative f of x. Or you can also say because if you reflect the graph about the y-axis and then about the x-axis, it lays back down on top of itself. So these are our two types of symmetry. And please note that not every function has symmetry. It might be even, it might be odd, and it might be neither, okay? So just to summarize, that if the function is even, that means f of negative x equals f of x. And then if the function is odd, that means f of negative x equals negative f of x. And neither means neither. So like in this problem, we're going to determine algebraically whether the function y equals x squared plus x is even, odd, or neither. So first let me check if it's even. And let me keep track of my work so clearly so that it's easy to understand. So f of x is x squared plus x. And then I also want to know what is f of negative x. So back to section 1.1, the first thing is just everywhere you see the x, you plug negative x. Okay, that's just evaluation of the function at a point. But then further, we want to simplify this. So negative x squared, that's negative x times negative x, that's positive x squared. And when I add a negative x, that's minus x. So firstly, we look and see if these two are exactly the same or not. If they're exactly the same, it's even. And if they're not exactly the same, it's not even. And I think you can see that this one has a plus on it and this one has a minus on it. So because these are not the same, that just means that the function is not even. But just because it's not even does not necessarily mean it's odd. It could be odd or it could be neither. So we checked this already. Now we're going to check, let me put it in the pink. Now we're going to check this, okay? So we need to compute f of negative x, which we actually already computed, and we need to compute negative f of x. So negative f of x, if you want, you can put a parenthesis like this. That means the negative of the entire y. So this is the negative of the entire x squared plus x. So this negative needs to be properly distributed so that this quantity will simplify to negative x squared minus x. Okay? Compare this to what's directly above it. So now the negatives match up okay, but what doesn't match up is that this is a negative in front of x squared, but this is not a negative in front of x squared. Okay? So these two are also not the same. Oopsie, I'm sorry. These two are also not the same, which means that this function is not odd. And so then in conclusion, because it's neither even nor odd, we say it's neither. Okay, you can only say it's neither once you prove that it's not even and also that it's not odd. Okay, so let's see a couple more examples, but they're all going to be exactly similar. Okay, so for part B, I have y equals x over x squared minus 1. This is f of x. So if I want to know if it's even, I have to do f of negative x. So everywhere I see x, I put negative x. So I have negative x over negative x squared minus 1. So when we simplify this, this is equal to negative x over x squared minus 1. So we're going to compare. And in fact, this isn't the same because the denominator is the same, but the numerator is different. So this function is not even. And then for odd, I need to compare f of negative x with negative f of x. So I'm going to compute negative f of x. So that just means you throw a negative on top of the entire y. So negative of x over x squared minus 1. When we simplify it, it equals negative x over x squared minus 1. So I have to compare this to the one directly above it. They're literally the same. So we can say that this function is odd. Odd function. Okay? So that's an example of an odd function, a little bit more complicated one, but you can always just like do it the same way. Okay? Number 5, we're going to determine whether y equals x to the 4th plus 1 is even, odd, or neither. So I know that f of x is given to be x to the 4th plus 1. Let me check if it's even. F of negative x is negative x to the 4th plus 1. And after simplifying, that equals x to the 4th plus 1. So these two are the same, already. So that means that the function is even. Okay, so as you see, it could be even, odd, or neither. You just need to basically check and see what's going on in each case. Okay, so this is our last example, the absolute value function, which is a piecewise defined function. This function is equal to y equals x when x is greater than or equal to 0, and it's equal to minus x when x is less than 0. And this is a little complicated to plug into, so we're going to do this one geometrically to find out what kind of symmetry it has. So what I'm going to do, as always, is I'm going to make a t-chart. Okay? So this is also like a good review of the piecewise functions. So when x equals -2, remember, you have to figure out what situation you're in. And in this case, when x is equal to -2, I'm in the second situation. So that means that I need to plug into the equation minus x. So here I'm going to have minus, well actually let me put it down below. Okay, I'm going to have minus of x. So minus of -2, which is 2. Okay, so this one is 2. And then when I have x equals -1, I'm also in the second situation, so I'm going to have the minus of -1, which is 1. Next, when x equals 0, that means we've switched so that we're in this situation. X is greater than or equal to 0, so I'm going to plug into x. So 0 comes in, 0 comes out. Similarly, when x equals 1, 1 is greater than or equal to 0, so I have 1. And then for 2, I have 2. So I go to plot the graph of this function. Okay, so I have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And the graph is approximately something like this. This is what the y equals absolute value x looks like. I'm sorry, it's like not going through the points. It should be. Okay. So then you have to say, well, does this have y-axis symmetry? Yes, it does have y-axis symmetry. And so because it has y-axis symmetry, that means that the function is an even function. Okay? So you can always solve it in the way that is most appropriate for the function given.